This is the last video from Objective 19.2, and this video goes over Part 3, which is special cases. So in factoring, there are a few special products that, if you can recognize them, can help us factor polynomials. So for now, we're just going to look at patterns when factoring quadratics. So there's a couple more that you'll learn later in like Algebra 2, but we're just going to focus on one special one, and it has to do with quadratics, and specifically binomials. Alright, so let's take a look at this special pattern. It's the difference of squares. When you have something squared minus something squared, it's going to factor as the square root of a squared and the square root of b squared, and it looks like this. And so I'll show you how to use that. Basically, take a look at example 1a here. We have x squared minus 25, which is 5 squared. So both are perfect squares. And so we're going to put our two sets of parentheses. I'm going to take the square root of the first thing. So square root of x squared is just x. It's going to go here and here. And then I'm going to take the square root of the second thing, and that's 5. It goes here and here, and we put a plus and a minus. And we're going to do the same thing for the rest of these as well, as long as there's not a GCF. So I really should have mentioned that first. No GCF on x squared and 25, but on b there could be, so let's take a look. Between 4 and 81, there's no GCF, so we're going to do the same thing. We're going to do our two sets of parentheses. 4 and 81 are both perfect squares, so it will work. Take the square root of 4x squared, which is 2x, here and here. Square root of 81, which is 9, put it here and here. And we put our plus and our minus. And that's all we have to do. So on C, we notice that there's a GCF between 250 and 90, and that GCF is 10. So we're going to factor that out of both pieces. 250x squared divided by 10 is 25x squared, and 90 divided by 10 is 9. So now notice that the thing in parentheses is the difference of two squares. So we have 25 and 9, and those are both perfect squares. So our 10 is going to be part of our answer. We're going to do two sets of parentheses. Take the square root of the first thing, that's 5x, and the square root of the second thing, which is 3. And we have a plus and a minus, and that's it. So the only difference on example 2 is that we're going to take it one step further. So we notice that a is the difference of two squares, so we're going to do our two sets of parentheses. Take our square root of the first thing, we get x and x. Square root of 100 is 10. We have our plus and our minus, and we have our equal 0 on the end. So just like what we've done in the previous sections, once you're done factoring, we're going to set each factor equal to 0. And then we're going to solve. So we'd subtract 10, so x equals negative 10, and add 10, so x equals positive 10. Alright, I want you to go ahead and pause the video and complete B, and then unpause and check your answer. Okay, so check over your work and make sure that you got this correct. And then let's take a look at C. So the problem with C is that one side does not equal 0, and that's one of our requirements for when we're doing these. And so the first thing we're going to do is we're going to move this over. They're not like terms, so we're going to keep them separate. 36 and 1 are both perfect squares, so we can factor. So we're just going to go through this one more time. We take the square root of the first part, square root of the second part, plus and a minus, and then we're going to set each factor equal to 0, and then we'll solve. So we subtract 1, divide by 6, add 1, and divide by 6. So we end up with negative 1/6 and positive 1/6. And that's all there is to it.